So welcome to the video. Today we're going to take a look at how to do Pearson correlation on Jamovi. So we're going to do Pearson correlation when we have continuous variables and we want to know if there's a relationship between those variables. So in addition to looking at how to do the test, we'll also take a look at the assumption of the test and how to check and report those, and we'll take a look at how to report the results of the Pearson correlation itself. So for this example, we're going to imagine that we are interested in the relationship between how many hours someone works in a week and how many days during the week they feel stressed. So let's take a look at how to put these data into Jamovi. So I have that Excel file there. So to import this, I'm just going to go to this bit at the top, then down to open, and then I'll just find that file on my computer. So now we have this data in Jamovi. So one of the assumptions of the Pearson correlation is that all of the variables are normally distributed. So to check this, we can go up to exploration, then down to descriptives. And then we can just transfer our variables over to this variables box. And then if we go down to statistics and find this Shapiro-Wilk box, we can tick that. Now we can see that we have these p-values for the Shapiro-Wilk test. So we want to see that these values are above 0.05, as that indicates that the data are normally distributed. So we can see for hours worked, we have a value of 0.37, as this is bigger than 0.05. That indicates that the hours worked data are normally distributed. And the same thing here, we have a value of 0.88, as that's a bit bigger than 0.5. It indicates that the day stress data are also normally distributed. So that assumption has been met. If you find that this assumption has been violated, you might consider instead doing a Spearman correlation, and I have a video about that as well if you'd like to check that out. So in addition to normality, I have a list here actually. The Pearson correlation assumes that there is a linear relationship between the variables and that there is something called homoscedasticity. So we can actually create a scatter plot to check both of these assumptions. So to do that, we can go to exploration, then down to scatterplots, and then we just transfer one of the items to the x-axis and one of the items to the y-axis. It doesn't really matter which way you do it, but typically you would transfer the variable that might be thought of as the independent variable to the x-axis, and the variable that might be thought of as the dependent variable to the y-axis. In the case of correlation, we don't strictly have independent and dependent variables, but it makes more sense to think as being stressed as a result of hours worked rather than vice versa. But it doesn't really matter. So I'll just transfer this to the y-axis, and we can see that this has generated a scatter plot for us. I'll just tick this linear box down here as well, and that's going to put a line of best fit through the dots. And we can see that these dots are quite well represented by a straight line. So that is consistent with this assumption that there is an approximately linear relationship between the variables. With regard to the assumption of homoscedasticity, we want to see that these dots basically create a cigar-shaped pattern, which I think these dots do. What you don't want to see is these dots arranging themselves in a funnel-shaped pattern. So you wouldn't want to see a sort of triangle or funnel where these dots are much more spread out at one end of the axis compared to the other. So based on a scatter plot like this, you could also conclude that we have met the assumption of homoscedasticity. So now that we've checked those assumptions, let's take a look at how to run the Pearson correlation analysis itself. So I'll go up to regression and then down to correlation matrix, and then I'll transfer both of these variables to this box on the right, and we can see that we already have Pearson ticked here. So let's take a look at the results. So it's quite simple. We can see that we have a p-value here. This is below 0.001. As that is below 0.05, we can conclude that there was a significant relationship between days stressed and hours worked. And as we have a positive value here, we can conclude that the relationship is also positive. So the more days someone is stressed, the more hours they work. So let's just take a quick look at how to report these results. So I have an example here. So I've started off just by reporting the results of the Shapiro-Wilk tests. So I've said that Shapiro-Wilk tests suggested that hours worked and days stressed were normally distributed, and then I've just inserted some statistics. So let's just take a quick look at where those come from. So I've said W equals 0.95 for hours worked. So we looked at this table before. So here we have it. There is the Shapiro-Wilks statistic here. So hours worked 0.951. And in the example, I've just rounded that to 2 decimal places. And then I've said P equals 0.376. That's just coming from this row below. So we have this P value here of 0.376. And finally, we've got this N value here of 20. So that's essentially just the number of participants in the case of this example. And that's what we have in brackets here. And then we just have the same thing here for the days stressed variable. And then I said an inspection of a scatter plot suggested there was linear relationship between days stressed and hours worked, and that the assumption of homoscedasticity was not violated. And then I've just assumed that I would include that scatter plot as an appendix. So finally, how to report the results of the correlation analysis itself. I've said a Pearson's correlation analysis indicated that there was a strong, positive, and significant correlation between hours worked and days stressed. And then I've inserted these statistics. So let's take a look at where those come from. So R equals 0.85. So if I scroll down, we can see here we have Pearson's R is 0.851. So I've just rounded that to 2 decimal places. P-value is less than 0.001. That's what we have here. And this value here is the degrees of freedom. So that's 18, and that's what we can see in this DF row here. One final thing to look at is that I've said here that the relationship was strong, and that's based on these criteria that Cohen proposed in 1988. So we said that R values between 0.1 and 0.29 can be described as small, those between 0.3 and 0.49 can be described as medium, and those between 0.5 and 1 can be described as large. So we have this R value here of 0.85. As that is between 0.5 and 1, we can say that there was a strong relationship between these two variables. So that is essentially it. I hope that helps. If you have any questions, let me know in the comments and I will try to get back to you. Thank you for watching. See you next time.